So here they're asking us for a lot of information. We have angular acceleration, tangential acceleration, radial acceleration, resultant acceleration, and the angle. So we first should write down our givens. We have the mass of 7.20 kilograms, and then we have a delta theta of 4 revolutions. We're going to immediately convert to 8 pi radians. And then for the final velocity, this is going to be 26.5 meters per second, and it's from rest. We have a constant acceleration, so a constant angular acceleration, and r is going to be equal to 1.20 meters. So we can find omega by saying v over r. So this is going to be 26.5 divided by 1.2, and this is going to be 22.0833 radians per second. And at this point, we can say that we can start by answering at least part A. A says, what's the angular acceleration? Well, omega final squared equals omega initial squared plus 2 alpha delta theta. We know that this is going to be 0 because it's from rest right here. So we can say that alpha is going to be equal to omega final squared over 2 times delta theta. So this is going to be equal to 22.0833 squared divided by 2 times 8 pi. And we find that this is going to be 9.702 radians per second squared. So to find b, they're asking us for the tangential acceleration. This is simply going to be equal to r alpha. And we can say that tangential acceleration is going to equal to 1.2 times alpha, which we just found to be 9.702. And the tangential acceleration is going to equal 11.642 meters per second squared. For part C, they're asking us for the radial acceleration. So a rad equals v omega squared. And we can also say that, well, rather, we actually know omega, so we don't have to convert to anything else. And we can simply say 1.2 times 22.0833 squared. And this is going to equal 585.21 meters per second squared. Now for D, we have a resultant. So the resultant acceleration, this equals a tangential squared plus a radial squared to the 1/2 power. And this is going to equal, again, so the square root of 11.642 squared plus 585.21 squared. And we find that this is going to be equal to, a resultant is going to be equal to 585.326 meters per second squared. And to find the max, so D is not asking for the resultant acceleration, it's asking us for the maximum force. So the force is simply equal to mass times acceleration, or the acceleration resultant. So this is going to be a mass of 7.20 times 585.326, and this is going to equal 4,214.346 newtons. So this would be your answer for part D. This is the maximum force. And then E would be tangent of theta equals the tangential acceleration divided by the radial acceleration. Again, this is trying to find theta. So theta is going to equal the arctan of a tan over a radial, a rad. And this is going to be equal to arctan of 11.642 divided by 585.21. And we find that theta is going to equal 1.14 degrees. So this will be our answer for part E. And that's the end of the solution. Thank you for watching.